Question 10. So, basically, think of your way through this. We've got to find the coordinates of the point on the curve which is parallel to this line. So if it's parallel to this, it's going to have the same gradient. Now, what is the gradient of this line? The gradient is 8. So we need to find out where the curve has a gradient of 8. Now, how do we work this out? Well, we need to differentiate. So start off by writing y in a more favourable format. So the second term is 9x to the minus 1. We then differentiate to get this, which tidies up to this. And again, given that we're going to be substituting into it, I think it's best to put this x to the minus 2, take the x downstairs again, so make that 9 over x squared, so minus 9 over x squared. Now, parallel to the to this line, as I said, so it needs to have a gradient of 8. So we set the differentiated form to being equal to 8. So then multiply through by x squared to undo this dividing by x squared gives us this, which tidies up to this. Now here we've got to note that this is one of those where we've got x to the 4 and then x to the 2 and x to the 0 effectively, so we can use the substitution of letting k, for example, equal x squared. So if we do so, then we actually change this into a quadratic which can be factorized and solved. So we can work out that k is minus 1 and k is 9, so x squared is minus 1, x squared is 9. Well, you cannot square root minus 1, so there's no solutions coming from this, but from this we get two solutions, x being 3 and minus 3. Now for both of these we need to work out the y coordinate, so we need to substitute our values for x back into the original curve, which I've done here and here, giving us a final answer of the two coordinates where it's parallel to that line of 3, 12 and minus 3, minus 12.